All right, so we're going to look at the MCAT prep with the nerve conduction test. And it says a nerve conduction velocity test is an electrical test that is used to evaluate the function of nerves. An NCV on a patient's sciatic nerves, which has a length of 0.9 meters, reveals a conduction velocity of 50 meters per second. So let's draw our nerve here. All right. And so we're having a conduction velocity. Right. Conduction velocity where V equals 50 meters per second. And the length of this nerve spread out is D equals 0.90 meters. So it's a long nerve. So our equation of interest, we'll look at the definition of velocity. Velocity equals delta x over delta t. And so this question here, if we pull it back up here, let me see if I have it hanging out down here. All right, if I pull this back up, it says, how long did it take the impulse to travel along the nerve? How long did it take the impulse to travel along the nerve? So we're looking for how long. We're looking for delta t. So I'm going to change my variables around. I'm going to say v equals distance divided by time. This is a widely rearranged equation. We can rearrange this so we get v times t equals distance. You'll see that one come up a lot in future as we track things with a velocity, and we'll try to make dimensional things out of them. This is common. Or we can also do t equals d divided by v. So we have three variables, and we get multiple equations out of manipulating these. So multiply both sides by t, divide both sides by v, we get this. Multiply both sides by t, we get this, and we got the d isolated. So we get a lot of usage out of this definition. So v equals d over t. And we have a way of expressing it for each of the three variables in interest. So let's plug in our knowns. So we have 0.09 meters over 50 meters per second. Dimensionally, the meters will cancel and the seconds will come up, so this is good. And so we run to our trusty calculator, 0.9 divided by 50. And that's 1.8 times 10 to the negative 2. And 1.8 times 10 to the negative 2, 1, 2, so yeah, 1.8, 0.018 seconds. Okay, 1, 2. And this answers the time it takes for an impulse to travel along the sciatic nerve.